Okay, I have written this change in kinetic energy. So work done by all the forces, change in kinetic energy formula. So now you can see, let me take a flywheel is rotating with the initial angular speed. A flywheel is rotating with the initial angular velocity, angular speed actually. Initial angular speed 60 radians per second. If moment of inertia about axis is 5 kilogram meter second square. Clear everybody? All of you? So question is now, due to friction of axle, it stops in 5 minutes. How many minutes? Everybody? 5 minutes. Find the work done. Find the work done by frictional force. So that is the question. Find the work done by frictional force. So imagine there is a flywheel which has been attached to the certain thing. So definitely there will be a friction. So we all knows that suppose if I try to rotate this wheel and if I leave it, so definitely after a certain time it will come to rest or not, everybody? Automatically it will come to rest because of frictional force. Am I right, guys? Please respond. If I turn it and if I leave it, after a certain time automatically the wheel will come to rest. Is it right or wrong, everyone? Yes. So because of axis of the frictional force which is produced by, you can see that if you go to any park and all, you can rotate the wheels are there like exercises. So you can rotate it, and if you leave it, the automatically after a certain time it will come to rest because of frictional force. Now the same question here, we have to calculate it. So now options, it is 5000 joules, option B 9000 joules, option C 16,000 joules, and option D 24,000 joules. So that's all it is. So you can just apply work energy theorem. So work done by all the forces is equals to what, everybody? Change in
Kinetic energy.
kinetic energy. So that's all. That is what final kinetic energy minus initial kinetic energy. So what is the final kinetic energy? Body stops, guys. Body stops means what is the final kinetic energy? Everybody? Body stops.
0.
Yes. So body stops means final angular force velocity is 0. So the final kinetic energy is 0 minus what is the initial kinetic energy? Initially body is revolving with 60 radians per second. How much it is? 60 radians per second. Am I right or wrong? Everybody, please respond. So minus I omega I square. So which is equals to, what is the I value? Everybody? I value how much, guys? Yes, please. Sorry, half. Half is missing. So half into, what is the I value they mentioned? Moment of inertia. Check it, everybody. 5 into,
5.
what is the initial velocity? Initial angular velocity. 60 square. Clear? So 60 square means, what is that? 1 by 2 into 5 into 60 square means what? 60 into 60. So 2 ones are 2 30s are. So 5 threes are 15. 15 6 are how much? 90. So which is equals to minus 9,000 joules. But here why minus is coming, everybody? Because direction of motion, frictional force is always opposite to the what? Everybody. Frictional force is always acting opposite to the direction of motion. So that is why. So work done is equals to work done by the frictional force is how much is the answer? Everyone? Yes, please. 9,000 joules. I hope you all understanding. So anything doubt you can ask. Clear everybody? Yes.
Yes,
So
sir.
final kinetic energy of the body is 0. Why it is 0? Because it is coming from this. So if it is comes to the rest means final kinetic energy 0 or not? Everybody respond. So that is why it is. Are of you clear?
Yes,
Yes,
sir.
for those solving on
Yes,
Narayan,
sir.
Pradeep, Mr. Sai Karthik, anything doubt you can ask. All of you understood or not?
Yes, sir.
Yes. So now this is what is work energy theorem. So now I am going to say you what we already studied, conservation of mechanical energy. So you might be remember that already we have studied in the last chapter. So conservation of mechanical energy, if you have taken. So can you tell me what is the formula of conservation of mechanical energy? We have studied it. Anybody? Conservation of mechanical energy. What is the formula? Everybody? Respond, Ra. Initial mechanical energy is equals to final mechanical energy. So that is what is the things. So what is the initial mechanical energy? Everybody. Initial potential energy plus initial kinetic energy is equals to what is that, everybody? Final potential energy plus final kinetic energy. So this is only the formula for conservation of mechanical energy. Do you all remember, everybody? Please respond. All of you? Yes, please. Conservation of mechanical energy. Initial kinetic energy plus initial potential energy equals to final potential energy plus final kinetic energy. Right or wrong? Respond, Ra. That is only that.
Yes,
So if you
yes,
notice it, what are the conditions we have taken when you are teaching conservation of mechanical energy? When all the forces what? Everybody. When all forces are what forces? All forces are conservative forces. So means like they all are gravity forces, spring forces, and etc. So no conservative, non-conservative forces are existed. No non-conservative force. What do you mean by example of non-conservative force? Anybody? Yes, please. No friction. So no friction means it is a what, everybody? It is a frictionless surfaces. Frictionless surfaces. Okay. And as well as no external force done by the body. No external force. External force is not existed. Means what is the work done by the external force? Anybody can tell? Work done by the external force is equals to how much? 0. That is what you have to remember. External force. Work done by external force is equals to how much, everyone? Please respond. External force is equals to 0. So this is what conservation of mechanical energy, which we already studied. So conservation of mechanical energy means what? Final mechanical energy is equals to initial mechanical energy. So mechanical energy means what, guys? Everybody, can you tell me? Mechanical energy means what? Mechanical energy is equals to potential energy plus kinetic energy. Am I right or wrong, everyone? Yes, please respond. So that is what. So
yes,
initial mechanical energy equals to final mechanical energy. So let us see now. Okay, so this is what you have to remember. When all the forces are conservative, means it is gravity, like spring forces. We have already studied conservative and non-conservative forces. So similar to it is. Non-conservative forces means no friction, it is existed. It is a frictionless surface. Okay, now let us take one question and we can solve. So let me take having a mass m and having a length L. So that is the rod I will take. So there is a rod whose length is L and mass is M. Mass is how much, everybody? M.
yeah.
Where it has been pivoted at this point. Where it is pivoted at this point. So now at this point, if it is pivoted means we already knows. Last classes we have studied that. So force exerted in normal reactions, it will be in two different directions, that is N1 and N2. So it is a what surface actually it is? It is a frictionless surface because no non-conservative forces. So it is a frictionless. So just imagine the weight of the body is acting at the COM. At the COM, weight of the body is acting downward directions. So this body has been released. Just I released it. So if I released it, the question is now, what is the work done? Understanding? Work done when the body has been reached exactly perpendicularly to the initial position. So this is what is the question. So what is the work done when the body has been displaced? It is just released. No friction, guys. No friction is exerted. So please all of you observe. No friction is exerted. So at this time, what is the work done? We have to find. So that is what work. What is the mechanical energy formula? Work done is equals to find initial potential energy plus initial kinetic energy is equals to final potential energy plus final kinetic energy. Work energy theorem. So conservation of mechanical energy. Now, if you notice it, when the body is at rest initially, so this is the baseline. So when the body is at rest, initially baseline it is. So baseline means what is the potential energy? For those baseline potential energy is what? Everybody. Initial potential energy equals to 0. When the body is in rest, kinetic energy also. Initial kinetic energy is equals to what? Everybody? Initial kinetic energy equals to also 0. So initially the body is at rest. So kinetic energy is 0 and potential energy also 0, which is equals to final potential energy. So that is very important. You can see body is released so that it is going down. Going down means negative up or positive up. We already know. From the beginning we are studying. So coming down, it is positive or negative? Everybody? It is negative. Minus coming down means it is negative. Understanding? And coming down it is, you can see. So mass is M. Mass is M. That is what is the potential energy formula? Anybody can tell potential energy equals to what? mgh. So M I got it. G value G and H is only important now. See, all of you observe whole mass is exerting. That is what? At the center of mass. That is what? Weight. Now, what is the displacement of the center of mass from here to here? Anybody can tell me? We should not take whole rod. If I take the whole rod having a length L, so only center of mass is displacement. How much it is? Anybody? You have to consider only center of mass. COM has been considered. So if I consider COM, how much it is displaced? Everybody, for those. So this point is here, this point is here, this point is here, like that. COM is traveled how much distance? Everybody, L or L by 2, center of mass. All of you. It is traveled only, center of mass is displaced only L by 2 distance. So the potential energy of the body is mg L by 2. And why it is negative? It is coming down. That is why it is negative. Plus, what is the final kinetic energy? Anybody? Final kinetic energy is equals to half into I into omega square. So that's all it is, which is equals to half into I into omega square is equals to mg L by 2. So now we all knows that when the rod is like this, so what is the moment of inertia through axis of rotation? Everybody under the center of mass. 2 moment of inertia. Tell me everybody. Moment of inertia to this axis of rotation. ml square by 3. Here what is
ml
the inertia? Everybody. ml square by
12.
Yes, please. ml square by 12. So that's all it is. So half into, we can substitute moment of inertia through axis of rotation. That is what? ml square by 3 into omega square, which is equals to m into g into L by 2. So now you can see everything. So half and 2 will get cancelled. M and M will get cancelled. L square and L will get cancelled. What is remaining? L omega square divided by 3, which is equals to, sorry, we have to find what is the angular momentum, W. Angular momentum we have to find. So which is equals to, what is remaining
DG.
here? G is remaining. So L omega square divided, which is equals to 3g. Omega square is equals to 3g by L. So what is the angular velocity? Everybody. So angular
G by
velocity
L.
equals to root 3g by. So this is how you have to solve it. Okay. So this is what. So here the main important thing is, all of you observe very carefully. We should not take the total length of the rod. Understanding? So length of the rod is displacing. Length of the rod is L, means here also it is not potential energy. L is displacing. So you have to take it only what, everybody? Center of mass alone. So center of mass, because whole force, the force is exerting only at the center of mass. So center of mass is traveling how much distance? From here to here, it is traveling only L by 2 distance. So that final potential energy is mgL by 2. That is what you have to solve. Clear, everybody? So if you solve this one, you will get the answer. W is equals to angular velocity is equals to root over 3g by L. That's all you have to do it. Clear, everybody? Understand, Amma?
Yes, yes.
Okay. So till here you solve it, and then from here we'll continue. So this is very important concept. So please, entire rotational dynamics is important only. So you have to go through that. Okay. Clear, everyone?
Yes.
Yes, sir.
Okay, so with this I'll stop and we'll continue from here. So please kindly practice and then only we can proceed. Okay, thank you.